Okay, so the topic of my presentation is some specific consideration for application of rather new concept on resilience in nuclear industry. So firstly, I will introduce myself. My name is Alexey Divach. I'm a chief scientific investigator in the Pukhov Institute for Modeling in Energy Engineering. And so the idea of this presentation is just to give you a brief outlook how this rather new concept could be applied in quite strict and boundaried nuclear power plants domain. So a few words about introduction. So we see the growing interest on
Sorry,
applying.
but we cannot see your. Sorry, but we cannot see. Oh, now we can see. Okay.
Okay,
Please
so
continue your presentation.
okay, thanks. So we are seeing a growing interest on applying the resilient concept to critical infrastructure, and usually nuclear energy sector is regarded as a typical critical infrastructure. So, for example, according to the quite recent report from World Nuclear Association, so electricity generation in nuclear power plant is about 9%, and in Ukraine, I believe you know that it's more than 50%. So we are heavily rely on nuclear energy. So for us, this resilience for nuclear power plants is especially crucial considering our electricity market. So the first research on the resilient concept initiated after the Fukushima Daiichi accident. I believe you know that that accident was caused by a combination of seismic and tsunami, so-called HILP event. And so after that accident, so the accident gave a new insight for research in that direction. It's necessary to say the concept of resilient is still in the development stage with very limited application in the nuclear industry. As regards the definition, so at the moment being, there is no universal accepted definition of resilience for nuclear power plants. We can see the term in different publications. An example, International Atomic Energy Agency documents, but no official definition provided. The only reference I found, it was mentioned in technical meeting definition, that within the system operating in the context of nuclear operating plan, the resilience could be defined as the ability to effectively respond to everyday emergent and emergency conditions to preserve nuclear fundamental safety functions and sustain or advance performance. So this definition is quite different from what we can see for other um, industries, but it reflects to some extent the specifics of nuclear power plants. As regards to understand why it's important resilience in nuclear industry context, we can consider two practical cases. The first one is the Fukushima accident. Well known, it was a big challenge to resilience, and despite of multiple safety systems, the loss of power and cooling capability led to co-melting in reactor core and spent fuels storage facilities at the site, and this disaster shows the need to improve resiliency, not only to withstand hazards, but also keep the plant state in such conditions that allow us to recover the plant and to go back this plant in operation. Another example is loss of offsite power accident is quite frequent in Ukraine now. Perhaps you know on the present piece, offsite power uh, was lost several times. It's challenge for nuclear power plant, but so in NPPs we have multiple layers that provide us with different means to provide electric supply to heat removal system, and we still can keep our plant in a safe state. But this is accident situation, and definitely we have to avoid such kind of accidents. I mean, loss of offsite power accident. So continuing about IEEE approach, so the International Atomic Energy Agency classifies the NPP states into two main parts. The operational states, it's a normal operation and anticipated operating occurrences, and accident conditions, which means design basis accident and design extension conditions that could be split into two parts, without fuel degradation and design extension condition with the core melting. So you can see on the picture that the different um, conditions that could be at nuclear power plant, and it's quite clear that not from all end states you can recover your facility, because if the core melted, so if you have a melted fuel inside, so there is no chance to return the unit into operation. So I mean, to have strong resilience is very important to have your unit online back. So considering the specifics of nuclear power plants, a more complex definition could be suggested for resilience. So the first thing, we need to prevent deviation from normal operation caused by any initiating events and their escalation to anticipated operating occurrences. We have to manage the accident conditions, preventing the fuel damage or any radioactive releases, requiring any protective actions off-site. We so the set bullet is a restore plant operation, keeping fundamental safety functions, principle and safety functions. And the last one is to enhance plant safety and performance by learning from past events. Here is a quite famous, perhaps, picture for resilience that could be applied for different industries. That is interesting for nuclear power plants. As I mean, the uh, uh, the area uh, is this curve. So actually, it's meaning loss in electricity generation. So if you started with a normal operation, then some initiating event occurred. So your absorption and recovery capabilities defines the loss of electricity in case of the accident. So you can to some extent measure this resilience, considering times for absorption, recovery, and so there is some insights from metrics we can use for that. Here's very briefly these 4 phases of resiliency. It's quite a famous one. I tried to reflect some specifics and for example, preparations. We have in nuclear industry a lot of design measures and some organizational measures ensure that our design is conservative and could stand on any events considered. And the same story with the absorption. So we have a specific set of safety systems, safety features to cope and mitigate any accident scenarios considered. And but recovery, it's not very common to consider recovery phase for nuclear power plant at the moment, because we are focusing for safety to keep the facility in a safe state. But recovery is also important, and we need to think about that. And improvement is a normal practice in nuclear industry to learn not only your national experience or plant experience, but to use different sources of information we have provided by IEEE and other organizations. Here is some ideas on potential indicators how we can measure NPP resilience. Is quite so now we are using this loss of electricity generation. It could be measured as the area of the curve, as I said before. So it's time between disconnection from the grid and when we put the unit online back. So it's quite correlated with what nuclear industry using now. Loss of electricity generation is quite broad parameters that are using. Also, we can measure the resilience using recovery rate, robustness as one of the features of facility. Here is as I mentioned before, it's only introduction to the topic, so a lot have to be done to even consider implementation of resilience in nuclear industry. Here you can see the main major task for that. So firstly, we need to make a decomposition of this very complex system as a nuclear power plant, considering many factors. It's not only safety aspects, but security and safeguards aspects. We have a lot of different systems, considering the safety classification and so on. We have to develop models and methods how to quantitatively estimate this complex system. And since we have in nuclear industry a well-developed strategy on safety management, so it's very important to develop a good methodological document how to integrate this resilience concept into the current philosophy of ensuring safety at nuclear power plants. And the last slide provides basic conclusions that the concept of resilience hold promises for advancing the safety and operational performance at nuclear power plant. We have to keep in mind that the safety must be a highest priority according to the basic principle safety culture, and we need to perform more further research to bridge existing gaps by exploring methods and models for resilience assessment. So it's what very briefly I was asked to limit myself by 10 minutes. So yeah, I'm finished here. Thank you for your attention.
Thank you, Alexei. Thank you, Alexei, for your presentation. Do you have any questions to the Alexei? Okay, no questions. I have one comments to your presentation. When we show the phases of resilience, the final steps is recovery and improvement. That it is necessary to take into account that these processes can be also lead not only to recovery and improvement and to degradation and collapse.
Yeah.
And it is necessary to take into account these two processes, two phases. Then the system, the complicated system, does not have possibility to restore. It is not no another time in order to do the restoration work and so on, and degradation and collapse. And unfortunately, as for me, now in Ukraine energy power system, we have a degradation processes. Are you agree with me?
Yeah, I'm fully agree what you just said. So yeah, indeed, you can reach the state when the restoration is not possible. It's not possible from safety point of view. So I fully agree with that, and we see degradation at the pre-and PP end. Everyone know about that. Yeah, but yeah, actually, I agree what you said. Yeah, it's a very good comment.
Mhm.
Thank you.
Thank you, Alexei.
Okay.
So last presentation
I have a little
according
question.
to our,
Just a small
yes,
question.
please.
On the slide 7, what is represented by the vertical axis? Slide 7.
So 7.
The
Yeah.
vertical axis, what does it represent?
The idea was to put here it's like a plant state. So when the initiating event happened, so our plant was operating on nominal power, so it was like a normal state. It's like a condition when the event happened. So here it was normal operation.
Thank you.
Yeah, plant
That's all.
state.
As I understand, it's a readiness system to properly work.
Yeah, it could be saying in that way as well.
This level is maybe 200% readiness.
Yeah, exactly.
Mhm. Okay, thank you.
Thank you.